Third exercise number 3. Static stress analysis of a one-dimensional fixed beam. Aim to determine the maximum deflection, maximum bending moment, and bending moment diagram of a fixed beam subjected to static point load and uniformly varying load. So this is a uniformly varying load. Okay. So one end is the load at one end and load at other end are varying, uniformly varying. Okay. Fixed B means both ends are fixed. So by using FEMAP, the first step is create model node. So here first origin x equal to 0, y equal to 0, then click OK. And the second one is x equal to 10, y equal to 0. X equal to 10, y equal to 0, then click OK. And then the third one x equal to 10 plus 40 50, y equal to 0. So x equal to 50, y equal to 0, z always equal to 0, click OK. Then x equal to 75, y equal to 0, and next point is x equal to 100, y equal to 0. So x equal to 75, y equal to 0, then click OK. And the last point is x equal to 100, y equal to 0, z equal to 0, then click OK, cancel. Next, material selection, model material. So in the load, select AISI 4340 steel, then click OK, then click OK, cancel. And next step, assigning property. So model property. So in the material drop box, select AISI 4340 steel, element property type, select beam, then click OK. And the shape, here the shapes are rectangular bar 10, that is here the height is 10 and width is 10. So shape, the shape drawbox, select rectangular bar, height equal to 10, width equal to 10, height to 10 and width 10, then click OK, then click OK, cancel. And next to step, create element. So model element. So the property drawbox, beam property, then select vector. Okay. So vector base x, y, z equal to 0, tip x equal to 0, y equal to 1, z equal to 0. Then click OK. Then the cursor kept in the node box. Put the cursor on the node box. Then select node 1 and node 2. Then click OK. Then select node 2 and node 3. Then click OK. Then select node 3 and node 4. Then click OK. And select node 4 and node 5. So here in the node box, here the number is displayed, that is the nodal point 4 and 5. Here finally I choose 4 and 5, right? So it is displayed 4 and 5. Make sure the numbers is correct or not. Okay, then click OK, cancel. Then next, apply boundary conditions. So model load constraint, sorry, model constraint nodal. So here the both ends are fixed. So simply skip this title page by click OK. And here the fixed beam. So here I choose the leftmost corner node and the rightmost node. So the number is 1 and 5. Make sure. Then click OK. Fixed, because the both ends are fixed. So select fixed. Then click OK. Cancel. Next, here we go to apply. There is a two load we need to apply. So one is point load and another one is the uniform distribution load. So first here I go to give the point load. So model load, for fixed point we choose constraint. For load we choose nodal, load nodal, and select, simply skip this title page by click OK, and select the nodal point 4, then click OK. And this, make sure the force parameter, then untick Fx and Fy because the load act in the y direction, in the downward direction. So in the downward direction, that's why here minus 1000, the load is minus 1000, the load is minus 1000 because the load is the act in the downward direction, the y axis, and the load is 1000 Newton, act in the downward direction, so minus 1000. So minus 1000, then click OK, cancel. And next select model, load element. Here I go to give the, select this element 2, then click OK. So on element, distributed load on element. So here there is a two end A and end B. So here in this diagram, this side is the left side is the end A and the right side is the end B. So here act in the downward direction. So minus 25 in end A and 0 at end B. Okay. So this is very important. End A equal to minus 25 and end B equal to 0. Then click OK. Then click OK. Cancel. And next step is analysis. Model, analysis, new, and in the analysis type is static. Then click OK. Then analyze. It will take some time for load results. The entire steps is analyzed by the software. So load result is displayed. So in this no load result there is no error. So continue. Next step, here we go to view the result. So in the view, select deform stylus deform and deform and contour data button. Make sure that deform is total translation. Deform in the deform drop box, there's a number of options are there, but we need total translation. Then click OK and OK. This is the first result. And next, view the beam diagram. So select view, select deform stylus none and contour stylus beam diagram. Then click deform and contour data, and in the contour data drop box, beam NDA plane 1 movement, the identification number is 3014. Select it and then click OK and OK. So this is the beam diagram of the given simply fixed beam. Okay. Thank you.